Welcome students. Today we discuss another most important distribution, that is called T distribution, generally known as Fisher's T distribution, that is included in the syllabus of B.Sc Mathematics Honours, B.Stat and B.Tech Engineering. So now we discuss what is T distribution and what is the probability density function of T distribution. So here we discuss first the standard normal variate N01. You know the probability density function, and we discuss it in our previous class. What is normal N01 variate, that is mean 0 and variance 1. And another distribution, you know, we discuss also in our previous class, that is chi-square distribution, and with the degree of freedom. So if X is a N01 variate and chi-square has a distribution with chi-square n degrees of freedom, then the random variable of the form T equal to X divided by root over of chi-square by n is distributed as T with n degrees of freedom with probability density function gamma of n plus 1 by 2 divided by gamma half into gamma n by 2, gamma of n plus 1 by 2 divided by gamma half into gamma n by 2 into 1 by root over of n, 1 by root over of n into dt by 1 plus t square by n whole to the power n plus 1 by 2, where t belongs to minus infinity comma infinity. So today we discuss the T distribution and deduce this T distribution. Here T is the random variable T is X divided by root over of chi-square by n, where capital X is N01 variate and chi-square is a chi-square distribution with n degrees of freedom. Now let us write the joint distribution. Let us write the joint distribution of X and chi-square distribution. Joint distribution of X and chi, that can be written in the form some constant into e to the power minus half into x square plus chi square into chi to the power n minus 1 d of chi, where minus infinity less than x less than infinity and 0 less or equal to chi less than infinity. This is the joint distribution function of the standard normal variate N01 with mean 0 and variance 1 and chi-square distribution with n degrees of freedom. Now it transformed into polar using x equal to r sin theta and chi equal to r cos theta, then r square equal to x square plus chi square, where 0 less than equal to r less than infinity, and theta, here theta varies from minus pi by 2 less or equal to theta less or equal to pi by 2. Because you know here from this transformation chi cos theta equal to chi by r, where both are positive. And if we look about the graph of cos theta, then we see that the cos theta distributed over minus pi by 2 is all over positive. Here cos theta is positive. So from this condition chi equal to r cos theta, theta distributed from minus pi by 2 less or equal to theta less or equal to pi by 2. Now the Jacobian is modulus of Jacobian, that is determinant of del of x chi del of r theta, and we previously proved already that is equal to r. Then the joint distribution of r and theta, that can be write as from this some constant into e to the power x square plus chi square. Here you know x square plus chi square equal to r square, so this is equal to minus r square by 2 into chi to the power n minus 1. Here chi equal to r cos theta, so it is r to the power n minus 1 into cos to the power n minus 1 theta, and d of chi. What is d of chi? Here chi is d of chi from dx. Here it is also the joint distribution, so it is dx into d chi, joint distribution, and here it is Jacobian into dr into d theta. So from the joint distribution of x and chi, if we transform into polar from x chi to r theta using the transformation x equal to r sin theta and chi equal to r cos theta, the Jacobian equal to r, and joint distribution of r theta can be written as constant into e to the power minus r square by 2 into r to the power n minus 1 into cos to the power n minus 1 into r, the Jacobian dr d theta, where r varies from 0 to infinity and theta varies from minus pi by 2 less or equal to theta less or equal to pi by 2. Now from this it is obvious that the variable r and theta are independent. The two random variable r and theta are independent, so the marginal distribution of theta can be write as constant into cos to the power n minus 1 theta into d theta, where minus pi by 2 less or equal to theta less or equal to pi by 2. As it is the probability density function, and you know for a probability density function minus infinity to infinity fx dx, if fx is a probability density function, then this is equal to 1. So we find the constant k. Such that k into minus pi by 2 to pi by 2 cos to the power n minus 1 theta d theta, that is equal to 1. And we deduce this result as k into 2 into 0 to pi by 2, as it is the even function, so minus pi by 2 can be written as 2 into 0 to pi by 2 cos to the power 2 into n by 2 minus 1 theta sin to the power 2 into half minus 1 into theta d theta, that is equal to 1, and therefore k equal to 1 divided by beta of half comma n by 2. You know beta mn, the beta function beta mn equal to integration 0 to pi cos to the power 2n minus 1 theta into cos to the power sin to the power 2m minus 1 into theta d theta. So from this, if we apply this here, then the constant k can be find as 1 divided by beta of half into n by 2. Therefore the distribution function Therefore, the distribution function of theta can be written as 1 divided by beta of half comma n by 2 into cos to the power n minus 1 theta d theta. Cos to the power n minus 1 theta d theta, where minus pi by 2 less or equal to theta less or equal to pi by 2. Now, here t equal to, what is t? Here t equal to x divided by root over of chi square by n. What is x? X is r sin theta, and what is chi square? Chi square is, chi is r cos theta, so it is r square cos square theta. From this we get r cos theta, and this root n is the numerator. From the numerator we get here, therefore t divided by root over of n equal to tan theta, and therefore t square by n equal to tan square theta, and 1 plus t square by n equal to 1 plus tan square theta, that is equal to sec square theta, and therefore 1 divided by 1 plus t square by n equal to cos square theta, that is equal to cos to the power sec square theta. From this 1 by cos square, so 1 by 1 plus t square by n equal to cos square theta, and that can be written as cos theta equal to 1 divided by 1 plus t square by n whole to the power half. From this we get cos theta equal to 1 by 1 plus t square by n whole to the power half, and from this we get 1 by root over of n. From this, differentiating both sides with respect to theta, we get 1 by root over of n dt d theta, that is equal to sec square theta, and that is equal to 1 plus tan square theta, and that is equal to 1 plus t square by n, and therefore modulus of dt d theta equal to root n into 1 plus t square by n, and from this we get d theta dt, modulus of d theta dt equal to 1 by root over of n into 1 plus t square by n. So the distribution of theta can be written as distribution of t, that is the distribution of t, 1 divided by beta of half comma n by 2 cos to the power n minus 1 theta. Here we can find cos theta equal to 1 divided by 1 plus t square by n whole to the power half. So therefore we get 1 divided by 1 plus t square by n whole to the power n plus 1 by 2, and d theta. From this d theta equal to 1 by root over of n 1 by 1 plus t square by n into dt, 1 by 1 plus t square by n into dt. Here it is n minus 1, because cos to the power n minus 1 theta, so it is 1 plus t square by n whole to the power n minus 1 by 2. Therefore, from this distribution of theta, we find distribution of t equal to 1 by beta of half into n by 2, half comma n by 2, cos to the power n minus theta. From cos to the power n minus 1 theta, we get this term, and from this d theta we get this, and simplifying we get gamma of n plus 1 by 2 divided by gamma half into gamma of n by 2. This is the beta function, 1 by root over of n, and from these two we find as 1 plus t square by n minus 1 by 2 plus 1, n minus 1 by 2 plus 1. From this we get n plus 1 by 2, so it is n plus 1 by 2 dt, and t varies from minus infinity less than t less than infinity. T varies from minus infinity less than t less than infinity. Therefore, the distribution of t, here we find gamma of n plus 1 by 2 gamma half into gamma n by 2 into 1 by root over of n into 1 divided by 1 plus t square by n whole to the power n plus 1 by 2 dt, and t varies from minus infinity to infinity. Therefore, we have already proved that if x is a standard normal variate with mean 0 and variance unity, and chi-square is a chi-square distribution of n degrees of freedom, then the random variable of the from t equal to x divided by root over of chi-square by n is distributed as t with n degrees of freedom. The degrees of freedom correspond to degrees of freedom of chi-square distribution. As chi-square distribution is a n degrees of freedom, therefore t distribution is also n degrees of freedom, and the probability density function of t, here we proved that probability density function of the distribution t is gamma of n plus 1 by 2 divided by gamma half into gamma n by 2, 1 by root over of n, 1 divided by 1 plus t square by n whole to the power n plus 1 by 2 dt, and t belongs to minus infinity comma infinity. I think you must follow this class, and this is a most important distribution. We have already discussed two distribution, and one is chi-square distribution, another is t distribution, and in our next class we discuss, you must follow this class and the next class, that is the moment generating function and the moments of t distribution. From this distribution, as it is contain the term 1 plus t square by n, so all the powers of t is even, so no odd moments are there. All the odd moments, all the odd central moments about the origin vanishes. So mu 2r plus 1 equal to 0. So we only find in our next class mu 2r, that is the event central moment. Thank you.